How can natural human gestures be utilized for a higher level of interactivity in a role-playing game environment by manipulating the user interface on a multi-touch display? The Labyrinth project is an interactive game which uses a multi-touch platform. It's based on the ancient Greek myth of Theseus and the Minotaur. The user will play as Theseus and will make his way through the labyrinth to ultimately try to kill the Minotaur. Throughout the game, the user will interact with other characters from the myth, collect objects, and face challenges that help him progress through the labyrinth and defeat his enemies. Theseus' journey, more specifically his path to claim his birthright as Prince of Athens, begins with the encounter of a string of 6 entrances to the underworld. The Greek underworld is known to have 6 gates that are guarded and controlled by spirits, disguised as thieves and bandits. Each entrance has a unique figure that guards it. The labyrinth therefore has 6 primary territories that must be crossed in order to reach the Minotaur. The player's objectives changes as he navigates further down into the underworld and also deeper into the labyrinth. The multi-touch screen interface makes the user handling very intuitive. Its manipulation can be used in different ways and for several functions. The labyrinth, together with the table, encourages discovery without instruction and accidental learning through physical interaction. Throughout the different layers of the narrative, users will be provided a mixture of gestures that will be used as input to complete certain tasks. The gameplay and game tasks can be easily learned from mere exploration, but a help guide will also be present to help the user find appropriate gestures. The Labyrinth ultimately aims to give the user a board game experience, but with different navigation and functionality methods. We have chosen to use a multi-touch table for the user interface and gameplay. The table will be a diffused illumination multi-touch interface. The touch projection surface is expected to be a 50-inch screen covered in semi-transparent projection material. We plan to use an ultra-wide short-throw projector to project the graphics directly onto the projection surface. The distance from the short-throw projection lens to projection surface is estimated to be 1.7 to 2.5 feet to create at least a 50-inch screen. The short-throw projector will keep our table slimmer, but we're leaving an option open to use a regular lens projector. We intend to use 2 Wisecom LED infrared illuminators to irradiate the projection surface. A sheet of Amscan plastic tablecloth will be used in conjunction with an acrylic sheet to construct the projection surface. Currently, we'll be using a PS3i camera with a wide-angle lens and IR bandpass filter to capture the reflected infrared blobs. To process the blobs, we will be using Community Core Vision software to take the video input from the PS3i and output the tracking data and events. CCV will then connect and communicate with Flash, which we'll be using to create the game application. The table chassis and skeleton will be made from a steel shelving unit and modified to meet our needs. The outside of the table will be designed with Greek aesthetics and Greek-style columns on all 4 corners. Sheet metal will be placed in between the columns to create a sealed table. The touch surface will be topped with a plexiglass frame, and the sheet metal will have fans, handles, and speakers built in. The color and coating of the table will have a texture that reflects Greek sculpture.